Okay, so we'll now have this topic, fluid mechanics. Okay, so we have three common phases or states of matter, right? So we have the solid, liquid, and gas. So when we talk about solid, it maintains a fixed shape and a fixed size. Even if a large force is applied to a solid, it does not readily change in shape or volume. When we talk about liquid, so liquid does not maintain a fixed shape. It takes on the shape of its container. So of course, we all know that. But like a solid, it is not readily compressible. So like solid, liquids resist compression. The volume of a liquid can be changed significantly only by a very large force. Then we have the third one, which is the gas. Gas has neither a fixed shape nor a fixed volume. It will expand to fill its container. So, well, for example, when air is pumped into an automobile tire, so of course the air does not all run to the bottom of the tire, right? So, uh, opposite sa liquid. So it spreads out to fill the whole volume of the tire. Since liquids and gases do not maintain a fixed shape, they both have ability to flow. Thus, they are often referred collectively as the fluids. So, ang fluid does not only refers to liquids, but also gases. Now, since we also have the fourth one, which is plasma, I think you've heard of it. Since the division of matter into three phases is not always simple, so we have here a fourth phase of matter, the plasma phase. So it occurs only at a very high temperatures and consists of ionized atoms that are those are electrons separated from the nuclei. So mo na ang plasma phase. Again, it occurs only at very high temperatures. Now we have here the definition for fluid mechanics. It is a branch of physical science which deals with the action of fluids at rest or in motion. So again, when we talk about fluids, it generally refers to gases and liquids. And with the application and devices in engineering using fluids. Fluid mechanics can be subdivided into two major areas. We have fluid statics, which deals with fluids at rest, and fluid dynamics concerned with fluids in motion. So again, fluid statics, it is a study of fluids at rest, and fluid dynamics, it is a science of fluids in motion. So under fluid dynamics, we have aerodynamics and we have hydrodynamics. So it deals with fluid flow. So the solution to a fluid dynamics problem typically involves calculating various properties of the fluid such as velocity, pressure, density, temperature as functions of space and time. So that is why we will discuss also the properties of fluid. So we have the very first property, pressure. So let us talk about pressure. So pressure is defined as the normal force per unit area. So again, pressure is the force per unit area. We have these terms, the unit pressure, absolute pressure, gauge pressure, but let us also include atmospheric pressure. So atmospheric. So atmospheric pressure by definition, it is the pressure due to the weight of the air. So it is the surrounding pressure nato. It is measured through an instrument called the barometer. So if you have a barometer measures basically the atmospheric pressure. So again, that is the pressure surrounding us. We have unit pressure, the force over the area, so that the unit of pressure now, like in SI units, we have the unit of force Newton over the unit of area meter squared. So you get the Newton per meter squared, or that is the unit called Pascal. No? That is the standard unit of pressure for SI. While for English unit, our force would be in pound force and your area in feet squared. So you have pound force per feet squared, or you can also have pound force per inch squared, square inch. So kaning pound force per square inch class, that is the unit commonly referred to as the PSI. That is the unit PSI, pound per square inch. Okay. Then we have absolute pressure. So by definition, absolute pressure is the true pressure measured from or measured above a perfect vacuum. So when we talk about perfect vacuum, that is when where things cease to exist, that is perfect vacuum. Then absolute pressure kuno is measured from the level of perfect vacuum, while ang gauge pressure class is the pressure measured from the level of atmospheric pressure. So on the next slide, we will have an illustration for that. So when you write class, since we have these different pressure pressure names, we have absolute pressure and gauge pressure. So atwa siyang i-subscript. As you can see, the absolute pressure is P, then subscript niya absolute. Then atmospheric pressure kaning PATM. Then PG, that is the gauge pressure also. Okay. And the gauge pressure, excuse me, we have, it is equal to the gamma, which is the specific weight. This is the symbol gamma. This is symbol for the specific weight and the height. So again, we will discuss this one further in the next slides. So we have this illustration. So unsa na ganito, we have the gauge pressure, we have the atmospheric pressure, and we have the absolute pressure. So as I have said, since ang absolute pressure is measured from the levels of perfect vacuum, so if at this level mao ni ang perfect vacuum class, so like for example, anhi nga level would be the pressure, the normal pressure nga ma-feel nato sa atong palibot. So in this level, we have the atmospheric pressure. So by the way, at standard atmospheric pressure, if not given in the problems, we have, if not given the problem, so you will use these values of atmospheric pressure class. This is at standard, the standard atmospheric pressure. We have 101.325 kilopascals. So when we say kilopascals, that is 1 kilopascal is 1000 pascals. Or actually, we have these values. So kaning sila tanan class, kaning sila. These are the values of atmospheric pressure in different units. Okay, we have different units manggod nga ginamit for pressure. So we have pascals. There are 101.325 pascals. So that is a value of atmospheric pressure, or 101.325 kilopascals. And then in pounds per square inch, ang atmospheric pressure nato is 14.7. Then, in the unit kilogram force per meter squared, ang atong value sa atmospheric pressure is 1.032. In inches of mercury, that is 29.92. In mmHg, so this mmHg, usually this is a unit of pressure nga makita nato sa kanang magpa-BP without that is pressure measuring device man, diba? The blood pressure, kana siya. Unsay tawag ana, speak mo man may terms ana. So kana siya nga instrument class ang usually mmHg. Okay, mmHg. So, ang absolute pressure na to, atmospheric pressure in mmHg is 760. That is also the value sa atmospheric pressure in torr. So, actually, these values, you must be able to at least familiarize or much better if you memorize these values. Okay. Then, the gauge pressure. So, as the definition ganina sa gauge pressure, it says that the gauge pressure is measured from the level of atmospheric pressure. So, if this is your atmospheric pressure, aning a level, so ang gauge pressure is either greater than the atmospheric, or it could also be less than the atmospheric. So, say for example, aning point, ang atuan ng gauge pressure since greater than the atmospheric man siya, no? So, positive ang atuang gauge pressure, anak class. Positive gauge pressure. While kung ani nga level, so as you can see, clearly see below siya sa atmospheric pressure nga level. So, ang atuan na ma-obtain nga gauge pressure is a negative gauge pressure. So, just like sa Cartesian plane, di ba? If this is your x, this is your y. So, ano yung origin? Pasaka ka positive, paubos ka negative y. So, tingali ang atua aning origin is kaning atmospheric pressure when we talk about gauge pressure. So, it could be greater than positive or less than the atmospheric pressure, so negative gauge. Also, ang negative gauge pressure is called the vacuum pressure. So, basta na ni term nga vacuum, meaning to say that the pressure, the gauge pressure is less than the atmospheric. So, kung naana ng word nga vacuum. Kung ma-picture out nato, unsa may ma-feel nato kung na vacuum. Naka-experience na ba mo na vacuum? Umingon ka, ala na vacuum siya. Umingon kag vacuum, mura kag suyupon, di ba? So, like for example, anang area na i-vacuum, anang area, aning area kinta, ni-vacuum ani. So, ni-vacuum na siya din ha, because at this area, negative ang atuang gauge pressure, meaning to say, ang pressure din is less than the atmospheric. So, ang nakapalibot din niya is greater than the levels atmospheric. Therefore, kung greater ang pressure diri is less than, so meaning maduot siya, no? Maduot siya. So, muna mura siya suyupon at this area, mura siya suyupon. So, naka-vacuum pressure na. So, kung negative gauge ang given, it is automatically vacuum pressure. Or, for example, there's the term vacuum, that is automatically a negative gauge pressure. So, that is why, kung ato ang tanawon class, at this level here, mao ni ang ato ang gauge pressure at this level here. And then, it is said that the absolute pressure is from the level of perfect vacuum. So, ang absolute, gikan sa perfect vacuum, padong, kung kuha na to ang absolute pressure din hinga point, so, gikan na siya sa level of perfect vacuum. Taman din, ha? Therefore, ang absolute pressure at this point is actually kani siya, which is its gauge pressure, plus this kani siya, which is the level sa atmospheric. So, therefore, we have the relation absolute pressure is gauge pressure plus atmospheric pressure. This is a very simple relation to that. Again, so at this level here, you get your absolute pressure from perfect vacuum to that point, which is actually equal to gauge pressure plus kinesia, the atmospheric pressure. So, therefore, if tagaan ka sa pangayuan ka sa gauge pressure, so gauge pressure, therefore, is absolute pressure minus the atmospheric pressure. So, that is why atmospheric pressure dapat ma-memorize na ninyo ang values. For example, ang units na to is in PSI, so you should know the value of atmospheric pressure in PSI, and in bar, so at least you should know the value of the atmospheric pressure in the different units. Now, also, kanisang value sa atmospheric pressure, we can, if you only memorize this, you can also convert the pressures from one unit to another. So, kanang mo na ihang conversion factor silbi. So, for example, we have this sample. Given the barometric pressure of 14.7 psi, make the following conversions. So, we have first 80 psi gauge. So, take note, so for the units, nasa gihapon na to ang subscript. So, when you say psi gauge, PSIG, so meaning to say that it is a gauge pressure. So, gauge pressure na siya. So, si 80 psi gauge. Convert na to psi absolute and to ATM or atmospheres. So, therefore, i-convert na to siya to psi absolute and also in atmospheres. So, kaya absolute man, so therefore, from gauge pressure, himuon na to siyang absolute pressure, no? So, from the relation, absolute pressure is gauge pressure plus the atmospheric pressure. So, given man si gauge pressure, that is 80 psi. So, ang atong i-add also nga atmospheric pressure should be in psi. So, pila ra to ang value? That is 14.7 psi. So that you have now the answer 94.7 psi. Now, since this is now the absolute pressure, so ato ang subscript din himay mo na siyang A, psi A. Okay. And then, okay na ni. Then, for atmosphere, so nag-change lang ta o mag-change lang ganitag unit, so we will use it as a conversion factor, the values of atmospheric pressure. So, PSI man ano from PSI, so dapat ang ato ang value nga PSI ato ang denominator so that we can cancel the unit PSI. So, the value of atmospheric pressure in PSI is 14.7. And then, padung ka sa atmosphere, so pila man na siya, that is 1 atmosphere. So that is why you can cancel lang PSI. Your new unit would be in ATM or atmosphere. So that is 6.44 atmospheres. Okay, letter B. For letter B, we have 20 inches of mercury vacuum. So we have the word vacuum. We have the term vacuum, so meaning to say that it is a negative gauge pressure. So it is a gauge pressure nga negative 20 inches of mercury. Then convert that one to inches of mercury absolute. Okay, daghan din siya. To KPA absolute pa gyud. And also to mmHg absolute. So from gauge, himo na to siya tanan to absolute, no, in 3 different units. So absolute pressure is gauge pressure plus atmospheric pressure. So since we are given negative 20 inches of mercury, so what is now the value of atmospheric pressure in inches of mercury? So we must add inches of mercury as well. So plus 29, the value is 29.92 inches of mercury. Okay, so our absolute pressure now is 9.92 inches of mercury. Now, since absolute naman na siya, that is, ang atong i-subscript is absolute. And then the next unit to solve is for kilopascals. We have the unit inches of mercury, the value of which in atmospheric pressure is 29.92 inches of mercury. Then, ato ka pa dun sa kPa, so the unit or the value of atmospheric pressure in kPa is 101.325 kPa. So that you can cancel the unit inches of mercury. You get now the unit in kPa absolute. So 33.59 kPa. This is now kPa absolute. Also, if we try to convert further into mmHg, so we have the value of atmospheric pressure in kPa is again 101.325. That is kPa. And in mmHg, that is 760 mmHg. So that you can cancel kPa nga unit. So, a new unit nimo now is in mmHg. This is now in absolute. So we have 257.98. Okay. And then lastly, we have 10 psi. This is your absolute pressure. Alright, so for letter C, we have absolute pressure. That is 10 psi absolute. Convert it to psi gauge and also to psi vacuum. So we have absolute pressure from the relation, that is gauge plus the atmospheric pressure. So if we are to get the gauge pressure, P gauge therefore is absolute minus the atmospheric pressure. So given absolute pressure 10 psi, so what about the unit, the value of the value of atmospheric pressure in psi? That is of course 14.7 psi. So we get now that is negative 4.7 psi. This is now gauge, psi gauge. And then kung maghisgot na tag vacuum class, you say the vacuum pressure is 4.7 psi vacuum. So mawala na ang negative nga sign, but instead na ang word nga vacuum. Or kung na kay vacuum nga word, dili na pud nimo butangan og negative nga sign since it is already redundant. Okay. Pressure in fluids. Okay, let us have this illustration. Suppose we have this container. Wherein natay liquid ani sa sulod. And then the height, with the height of the fluid inside it to be h. And since this is open to the atmosphere, so na pressure diha due to the weight of the air. And since open siya to the atmosphere class, so take note, if it is open to the atmosphere, ang pressure ana is atmospheric pressure. So that, like for example, in the ocean, at the surface of the ocean, ang pressure ana is atmospheric pressure. Like for example, you have a water tank that is open to the open ang iyang ibabaw. So the pressure at the surface anang liquid or tingali water inside the tank at the surface is atmospheric pressure. Like for example, we also have a glass of water. So the pressure of the water at the surface of the water inside that glass is also atmospheric as long as sa surface siya and it is open to the atmosphere. So right now, at this point, ano yung level sa to ang like for example, liquid is water. The pressure there at point A, butang ta point A. So pressure at point A is actually atmospheric pressure. Now, ano sa bottom of this container or tank? Suppose we have point B. So let us try to find out pila ang pressure at point B. Okay? Pressure at point B or PB. So from the definition of pressure, that is force per unit area, the force now nga itong gimin is the weight, no? The weight ani niya. Weight over the area. And then when talk about weight, weight is equal to mass times the gravitational acceleration. And then from the density definition of density is mass per unit volume. So therefore, the mass of that liquid is now equal to the density of the liquid times the volume of the liquid, right? So cross multiply na nato. So mass is density times volume. So therefore, dire mass is equal to density times volume, then times the gravitational acceleration over the area. And then when we talk about volume also, so volume is kung regular, suppose regular ni ato ang tank din eh. Kung regular ni siya. So volume is basically equal to the area of the base times height, right? So ang volume na to, this one, volume is area times the height. So this is now density times the volume, which is area times the height, then times gravitational acceleration over the area. Wherein, makancel out na to ang area, therefore, this is now rho hg, or we have the pressure to be rho gh, or rho g, this is now the quantity called gamma, or the specific weight, then times the height. So again, gamma is equal to, specific weight is equal to density times the gravitational acceleration. So this one is another relation in SIA class. And pressure, you get also the pressure using this formula. Rho gh, or gamma times the height. Again, saan in SIA? This is the density times the gravitational acceleration, then times the height, this one. Density of the fluid times the gravitational acceleration, then times the height. Or specific weight of the fluid times the height. Now, this is now the, kanisiya, this is now the gauge pressure at point B. Okay. Now, kukuha na to ang absolute pressure, diba? We have the absolute pressure is equal to the gauge pressure plus atmospheric. So gauge pressure is given by the formula rho gh plus atmospheric. So this is now your absolute pressure at point B. This one. Or kung tanaw na to sa figure, this is atmospheric, which is equal to PA, right? No? So PB is equal to rho GH plus PA. Now, kung ato ni siyang kanisiya class, kung ato ni siyang i-rearrange, say PB, bali na to si PA minus PA, is equal to rho GH. Kung atong analyson at point A, between point A and B, asa man ang, kung ato lang hunahon asa ang mas greater ang pressure, ani sa surface or ari sa bottom. Di ba, ari sa bottom, no? Like for example, mo dive ka sa dagat, magkaanam kag kalawom, magsakit imong daongan tungod kay the more you go deeper, magka dako ang pressure dito sa ilawom. So, mas greater ang pressure ni B than ni A. So, that is why greater ang pressure ni B minus ni A. Greater minus kamay nga pressure, so positive rho GH. Kung atong balihon, we have pressure ni A minus pressure ni B. Pressure ni A minus ang pressure ni B, you get a negative rho GH. It is because mas greater ang pressure ni B than A. So, lesser pressure ni A minus ano greater pressure ni B. So, that maka-answer ka og negative nga rho GH. Negative imong answer for that. So, that is just by looking at our illustration. So, pressure difference between 2 points, A and B. So, kanin siya. PB minus PA is positive rho GH. PA minus PB itong gibali is a negative rho GH. So, magkasaka siya, class. Kung from B kan ni B, magkasaka kag elevation, magka-negative ang pressure, magka-decrease. Kung magka-deep ka, ang imong pressure magka-increase. Okay.